Microsurfacing is similar to slurry seal. It consists of the application of a mixture of water, asphalt emulsion, aggregate or very small crushed rock, and chemical additives to an existing asphalt concrete pavement surface. Polymer is commonly added to the asphalt emulsion to provide better mixture properties. The major difference between slurry seal and microsurfacing is in how they break or harden. Slurry seal relies on evaporation of the water in the asphalt emulsion. The asphalt emulsion used in microsurfacing contains chemical additives which will allow it to break without relying on the sun or heat for evaporation to occur. Thus, microsurfacing is an application that hardens quicker than slurry seals and can be used when conditions would not allow slurry seal to be successfully placed. Streets that have a lot of shade and streets that have a lot of traffic are good candidates for microsurfacing. According to a recent eco-efficiency analysis of asphalt paving technology, it was found that microsurfacing is not only more economical, but it also causes less environmental impact than the traditional mill and fill strategy. The organization behind the analysis, BASF Corporation, details a wide range of methods used to determine the benefits of using microsurfacing to prolong the design life of road surfaces. The basis of the study revolved around the use of 2-inch mill and fill asphalt overlays and compared it to the cold mix, asphalt emulsion-based microsurfacing. The impact of both materials was measured on a 1-mile section of 12-foot lanes using each technology. Where pavement preservation is concerned, microsurfacing is quickly becoming a popular option due to the many perks it offers. By simply mixing aggregate, mineral filler, water, and a polymer-modified asphalt emulsion, it creates a very unique result. When coated on a road surface, it can accept traffic in as little as an hour and is an ideal solution for a heavily traveled roadway. As a road maintenance strategy, it is ideal for leveling a street and filling cracks as they begin to appear. The concept behind mill and fill entails removing the existing surface layer with a milling machine and then transporting the material to a storage facility. New asphalt is then used to replace the milled location, allowing for upwards of 7 to 10 years of durability. While the use of mill and fill entails for less frequent maintenance, the cost still proves to be quite significant. The final comparison revealed while microsurfacing requires a single application every 5 to 7 years, it maintains a low cost due to the decreased levels of aggregate needed to maintain road surfaces. Asphalt-based mill and fill requires hot production environments and applications in addition to more asphalt and aggregate than microsurfacing, which results in a 40% increase in energy expenditures over microsurfacing. From a material standpoint, microsurfacing requires less than 50% of the resources needed for mill and fill. Of all the contributors of land use in producing aggregate, mill and fill was identified as the largest contributor. Mill and fill, in comparison to microsurfacing, uses as much as 2.5 times as many aggregates, which thus requires more asphalt binder than used in microsurfacing. This increased level of materials and work is necessary to offer the same 40-year life cycle offered by microsurfacing. The resulting impact is that mill and fill requires 25% more work and cost despite the more frequent applications required for microsurfacing. In the end, the study proves microsurfacing is the more cost and eco-efficient strategy for maintaining asphalt pavement surfaces. It requires fewer materials, and while needing more applications over the long term, it still proves to be a more efficient strategy from a budgetary and efficiency standpoint for covering cracks and prolonging the design life of a roadway.